Hello, in this video I'm going to go over investigation 1.1.4. So like always on the first slide, is a chance for you to check in, let me know how you guys are doing. Okay. At the beginning of each lesson I have a focus question. So this focus question is, how can you represent multiplication using algebra tiles? Right. Taking a look at the first part, we're at A1. So this rectangle here has a base 3 and a height of 2. What's the area? Well, if you know your multiplication, you can always do 2 times 3, which is 6. And the way that's shown by the tiles is, notice that I can fit 6 of these squares inside the space here. So that's 1, 2, 3, 4, 5, 6. So you can think of this area as 6 square units. 6 squares can fit inside this shape. 6 squares can fit inside the rectangle. So moving on to the next slide, A2. One way to think about multiplication is in terms of a rectangle's area. So if I move the slider, where do the tiles appear? Right. As I move the slider back and forth, notice that they appear along the base of the rectangle, right, where the bottom of the rectangle would be. So they appear along the base. Moving to the next slide. Okay. In this example, we have a base of 6. Move the blue dot on the side to make a height of 3. What is the total area? So this dot over here, I'm going to drag it down. Right now it's at height 1, height 2, height 3. So we can think of this as a rectangle with 3 by 6, or we can think of it as multiplication 3 times 6. So what would be the area? Again, you could think of it as 3 times 6, or if you can count on each of these sections, there are 6 across here, 6, another 6 makes 12, another 6 makes 18. So there are total 18 area to this rectangle. All right, moving to the next slide. So use the tiles to create the following multiplication problem. Height times base, or 6 times 8. So I want 8 across the base, so at the top, I want a base of 8. Okay, do you see how it gave me a check mark? And I want my height to be 6. So I'm going to drag this down, height of 6. So you can think of multiplication 6 times 8 as a 6 by 8 rectangle. Right? I can multiply this up, or I can just add up. There's a row of 8 here, so that's 8. Another 8 is 16, 24, 32, 40, 48. So this one has a total area of 48, or 6 times 8 is 48. Let's try the next one. All right, I want a 7 by 5, so 5 along the base, height of 7, so 2, 3, 4, 5, 6, 7. So I can multiply 7 times 5, or if I'm more comfortable with just adding, see, row of 5, 10, 15, 20, 25, 30, 35. There were 35 squares in this shape. All right, and the last problem, 4 by 15, so I want a base of 15. Scroll down the height of 4. So 4 times 15, or 15 of these 4s, 15, 30, 45, 60. This one has an area of 60. Okay, moving to the next slide. So far, we only looked at rectangles with positive sides. However, we can make rectangles with negative sides as well. So right now, this rectangle has an area of 20. I'm going to make this side negative. So I'm going to take this red dot. I'm going to flip this to become negative 5. So one more time. Right now, it's side positive 5. Now it's going to be side negative 5. Okay. So what happened to the areas? They're no longer blue. After I made one side negative, notice that the area is now red. So the area of this one, 4 times negative 5, the area is now negative 20. Right. All the tiles flipped over to red. Moving to the next one. So describe what's happening as the area as you make the base negative. As one side becomes negative, the area flips from positive to negative. So as the side becomes negative, the area flips from positive to negative. All right, moving to the next slide. We can also change the height to negative as well. So right now this one has an area of 32 because 4 times 8 is 32. But if I make this side negative, so instead of being 4, it's going to become negative 4, right? negative 4 times 8, you see how the whole area is now red? The whole area is now negative 32. So when one side is negative, it flips it over and makes it into a negative answer. Okay. So now let's go in and do some practice problems. So I want a 5 by 12 rectangle. So base 12, height 5. All right, so I have 5 by 12. But again, the base is going to be negative. So I'm going to flip this to negative. So I know that 5 times 12 is 60. But if I make this negative, the area is going to be negative 60. Okay, moving to the next one. So here I have a 4 by 9 rectangle, 4 times 9. So 9 across the base, 4 for the height. And I know that 4 times 9 is going to be 36. But again, one side is going to flip over to negative. This is going to be negative. So when I flip this side to negative, notice that the whole area now becomes negative 36. Okay, and then for the next one, let's see, 3 by negative 16. So I want 16 across the base, 3 for the height. So 3 times 16, let's see, 3 times 10 is 30, 3 times 6 is 18. So right now this is 48, but I'm not quite done yet, because again, the base has to be negative. So if I make one side negative, if I flip it over, notice that all the area inside becomes opposite. It becomes negative 48. All right, so the last situation we need to look at is when both sides are negative. The original rectangle has an area of 20. So what happens when you change both sides to negative? So when the base becomes negative, notice that it becomes negative. But what happens when I pull this slider down? So if I make this one also negative, you see how it flips back? It's now become positive 20 again. So to explore that situation a little bit closer, notice that when the first side is flipped to negative, you see how it becomes negative. When I flip the other side, it flips back to positive. 2 flips, negative, then flip again, it goes back to positive. After the first flip, the area is negative. After the second flip, the area returns to positive. So you can think of it as when you multiply 2 negative numbers, when you flip twice, opposite and then opposite again, it returns to becoming a positive number. So let's try that here. I want a 5 by 8 rectangle, so base 8, height 5. Right? If I flip one side over, this is now negative, but if I flip it again, it's back to positive. So negative 5 times negative 8, if I flip it twice, I end up with 40 squares. All right, next example. Negative 9 times negative 7. So base 7, height 9. Okay. First flip makes it negative, but when I multiply by another negative number, it flips back to positive. So altogether, this is going to be positive 63. Okay. And here, 8 by 14, so base 14, height 8. So normally this would be an area of, let's see, 8 times 14, 8 times 10 is 80, 8 times 4 is 32, so 112. Normally this would be an area of 112. But again, if I flip one side, it becomes negative. But if I flip it again, it becomes positive. 2 flips, 2 negative numbers become positive 112. So how can we represent multiplication using algebra tiles? When I multiply 2 positives, I get a positive area. If one of the sides is negative, I get a negative area. When both sides are negative, it flips twice and returns to positive. Okay. All right, and then finally for the last slide is going to be a couple of multiplication problems. So again, you can try these on your own, and when you're done, you can double check your answer right here. So 2 times 11 is 22. 4 times 13 is going to be 52. 5 times 12 is 60, but don't forget that one side is negative, right? So it's going to have a negative area. 9 times 3 is 27. Again, one side is negative, so that would be a negative 27. Right, 4 times 6 is 24. And since it's two negatives, right, it flips twice, so it becomes negative, then goes back to positive. It's going to be positive 24. And then 5 times 7, that's going to be 35. Right, and then 2 flips becomes positive. Right, so that's going to wrap it up for this investigation. And if you have any questions, just let me know.